Jai Hind everyone. Welcome to the class of Data Communication Networks. Under Unit 1, this is the first video lecture and the topic will be Introduction to Data Communication and Addressing used with the Internet. So first of all, the contents that we are going to discuss in today's lecture are Introduction to Optical Communication Networks. We will also study what are the main goals or objectives of the data communication network. We will also discuss the applications of the network, and finally we will discuss the topic addressing in the networks with its type. That is, what are the different type of addresses that can be used with the internet or in the networking system. So first of all, we have to study the meaning of data communication network. So basically, data communication network is made up of three words, that is data plus communication plus networks. That is, to understand the meaning of data communication network, we have to understand the meaning of three words, that is data, communication and network. So what is data? Basically, there is message or information. This message or information cannot be directly used with the network. So this message or information in the case of computing needs to be translated into a form that is sufficient for movement or transmission, processing or storing. Generally, we can say that generally the information or message is in the form of, we have information or message. This message or information generally lies in the form of text, image, audio and video. Or we can say that the data representation form are text, image, audio and video. When we have to use this message or information in the case of computing, or whenever we have to share the message or information, it needs to be translated into a form that is more suitable for transmission, storing or processing. Or we can say that the information or message in this form is the raw data, and when we convert it into the corresponding digital or binary form, then the message or information becomes the data. Or finally, we can define the data as, data is nothing but it is the large amount of message or information generally in the digital form. Because when we talk about data communication, basically we are talking about computer communication networks, and in the case of computer, the basic form of understanding is binary, that is digital or binary. So the information or message needs to be converted into the digital or binary form. So we can say that the data is nothing but it is the large amount of message or information that is translated into the digital or binary form so that it can be shared over the network. Next is communication. Basically, communication is communication engineering. So basically we are going to define here is communication engineering. So communication engineering is nothing but it is the process of conveying information from one place to another place via electrical or electronic means. Now I am teaching, you are listening. So that is communication, but that is not communication engineering. For the communication engineering, it is important to use the electrical or electronic means. That means electrical or electronic means we have to use some kind of device, equipment and processes. For example, we have to use transmitter having transmitting antenna, and in the transmitter we can use some processes like encoding, modulation. Similarly, we will require some kind of channel or media for carrying the information from one place to another place. The channel or medium can be wired or wireless. For example, that can be the optical fiber cable, coaxial cable, copper wire, metallic waveguide, or maybe the free space or atmosphere. So we have to use some kind of channel. Similarly, on the receiver side also, for conveying the information, we have to use some kind of devices or equipment and processes. For example, we may require receiving antenna, and in the receiver, we may require the processes like decoding and demodulation. And in the receiver side, to recover the message or information in the original form, we require some additional devices or equipments or maybe processes. For example, filtering is required, and to remove the noise, we use filter, and we may also require the equalizer to remove the distortion. Equalizer is also required on the receiver side. So that means communication engineering is the process of conveying information from one place to another place via electrical or electronic means. That is, we have to use some kind of devices, equipments and processes for carrying the information, that is using the transmitter, receiver and channel. Then what is network? Network, basically for conveying the information, we require an overall infrastructure to support the communication. This overall infrastructure is termed as the network. So we can see that network is nothing but it is the collection of computers, servers, mainframes, network devices, peripherals and other devices connected to each other to allow the sharing of data. That is, to allow the sharing of data, we have to use a number of devices, equipments, computers, servers, and together they form, when connected with through a particular medium, that is known as the communication link. So when link is established and all these devices are connected, combined together for sharing of information, that is termed as the network. Examples of network or popular examples of network can be, for example, internet. It is the global network, combination of all different type of networks. Then we have telecommunication network for landline telephone. This is another example of network. Another example of network is optical network, when we use the components as the optical components and the channel used is optical fiber, that is the optical network. Then for mobile communication, nowadays we use the mobile network to support the mobile communication. So in combination, what we can say that data communication network is the data communication networks are the networks which are used for sharing of information, large amount of information in the digital form from one place to another place via electrical or electronic means. That means we have to use some kind of devices, equipments and processes. So that is the data communication network. So here we have summarized the main goals of networks. What are the main goals, or we can see that the objectives of the network. The main goals or objective of the network are such as to deliver data to the correct destination. So data must be delivered to the intended destination or where it should go. It should not happen that data is delivered to the wrong destination or the wrong user. Another important objective of the network is to deliver good performance, and this good performance must be measured in terms of delay and throughput. We will say that a network is performing very well when the delay is minimum. when the delay is minimum, or we can say that the real time application are there. Then we have throughput. The throughput of the system must be high so that the system can perform very well, or we can say that this is the measure in terms of data output, throughput. So a good performing network will have the minimum delay and throughput should be high. A network should also support the multi-user applications. Next, to ensure the high-speed data sharing between the computers and devices, this must be one of the properties of the present day networks, because nowadays the requirement is that data speed should be very high. Next is, data network must ensure the reliable communication with good availability and ability to recover from the failures. That is, a network should be highly reliable. Whenever we look for the network availability, it should be high during the observation period, and during the disaster time or during the failure time, the network should have the ability to recover itself. Another feature of the network should be secure communication with minimum data loss and reduced errors. The network should provide the features of network security, and data loss should be minimum along with the length of the communication, and then reduced errors, accuracy of the data transmission should be very high over the network. Then no jitter, that is, when the packets are arriving in the network, there should be minimum variation among the arrival time in the packets. Next we discuss is use and applications of the network. The most popular applications for the data sharing are instant messaging service, email, that is most commonly used nowadays, file transfer applications, information sharing using the web or internet, mobile data communication, telecommunication, video conferencing, optical network based applications where large amount of data in the gigahertz or gigabits per second are transferred, and then high speed data sharing applications between the computers and devices. Next topic we are going to discuss is addressing. Addressing means what are the different type of address that are required for sharing data over the network or internet. Actually, when we share the data or information over the internet or over any network, a number of addresses are required. For example, if we are using the internet and we are employing the TCP/IP protocol model, then 4 type of addresses are generally used. These are physical address, logical address, port address, and specific address. So as discussed, when we are using the internet using the TCP/IP model, 4 type of addresses are required. First type is physical address. Physical address is nothing but it is the destination address where data is to be delivered. As we are using the physical address and we are using the TCP/IP model, so this physical address is basically required at or will be used as physical layer and data link layer level. Okay, and this physical address is also known as the MAC address. MAC address, that is the LAN address or Ethernet address or the networking card address. So this physical address is basically used for delivering the data to the exact destination. Then we have logical address. Logical address is basically used at the network layer. In the IP model, this logical address will be used as the network layer. And logical address is nothing but it is the device address. Device address in the network. That is, whenever a device is connected to the network, it will require some identity in the network. That identity is logical address. For example, we can say the IP address, then we have port address. Port address is basically process to process address. Process to process address. This port address is basically the address that is used for uniquely identifying a process. Uniquely identifying a process in the network, then we have to use the port address. Port address may be, for example, the input and output port address. Port addresses are used at the, if we are using the TCP/IP layer, then this is used as the transport layer. Okay. Then finally we have specific address. Specific address is used at the application layer level. That is, specific addresses are required for accessing the network or using the application by the user. For example, if we are using an email, for email communication we require the address of the destination, that is email for the sender and receiver. Another example of specific address is when we have to access the internet, we can use, for browsing purpose, we use the URLs, that is Uniform Resource Locator. So URL can be used for the specific address. This is the relation of layers and different type of addresses used in the TCP/IP protocol model. As we have already discussed in previous slide, that the physical address is generally required at the data link layer and physical layer. Then logical address, that is IP address, is required at the network layer with the IP protocol. Then we have port address. This is for process to process communication or unique identification of process in the network. Then that is used at the transport layer. And finally, specific addresses. Specific addresses are used at the application layer level for accessing the network or services by the users. Here are some examples. Physical address. As we have discussed, physical addresses are required for exact delivery of data to the destination. So here we have a sender whose address is 10. Then we have a receiver whose address is 87. So we have data. Then at the data link layer level we have frames. So we have a trailer added into the data, and then we have header added in the data. This header has the source address 10. Then we have exact destination address 87. That is, for delivery of data we require the exact destination address 87. So when the data is transferred, at this point we will check what is the destination address. So it is not matching, so data will not be delivered. Again 53, this is also not matching, data will not be delivered. Then here we have the matching, so data will be delivered. So we require the exact address. This is one more example for the MAC address or physical address. Basically, the local area networks in the LAN cards, we use 48-bit or 6-byte physical address. So byte can be represented by 2 hexadecimal characters. So this 6-byte physical address can be represented as 6 bytes these are the corresponding 6 bytes in the hexadecimal form, separated by the colon from each other. So this is the representation of 48-bit or 6-byte physical address. In the computer systems, we have physical address or MAC address marked like this. This is for IP address. IP address are basically device address into the network. When any device is connected to the internet, it have a identity in the network. That identity is IP address. So we have local area networks and we have various systems connected to the network. So these will have identity in the form of IP address. So here we have the A for the sender and P is there for the another. Then we have the IP. Okay, so the IP address basically can be depending upon how many systems we are connecting into the network. These can be IP version 4 or maybe the IP version 6. Example can be, for example, 192.168.005.002. So this is one example of IP address. Next we have port address. As discussed, port address is for a unique identification of process in the transport layer. Example of port address can be, port address basically is a 16-bit address represented, and this is represented using a single decimal number in decimal form. So basically if we have a 16-bit address, the total addresses are 2 raised to power 16, that is 65536. So the port address can be any unique number in the decimal form which will have a range of 0 to 65535. 5. So any number in this range can be used as a port address. For example, this one example is the address of any port. These port addresses can be divided into 3 categories, like well-known ports will have this port address range. Registered ports will have the address range, this one. And then we have dynamic or private ports, in which the address port range is this one. So by simply seeing the port number, we can identify the type of port, whether it is a registered port, dynamic port, or well-known port. But all of these ports will have address in the range, this one. So finally, the specific address. Specific address is used for, are the user-defined addresses for accessing the resources over the internet or web. For example, URL, Uniform Resource Locator, for accessing any particular web page on the internet or website. So that is basically the link available in the address bar of the browser when we access any website or web page. Another example is email address, for sharing of data or information between the 2 users over the internet or through the mail service. We require the mail address of both sender and the receiver. So any email address is example of this specific address. So thank you all of you. Thanks for this lecture. And this is the main reference used, that is Data Communication and Networking by the author Foroche.